Hi everyone and welcome back to my channel in Economist. So in the previous video, we have learned about what is stationarity of a time series, and we have also described in details what is a weak stationary process and what is a strong stationary process. We have also understood the difference between them, right? So in this lecture, this is lecture number 5, we will understand some of the important covariant stationary processes. As I have told you, covariant stationary means nothing but the weak stationary, right? Covariant stationary process means the weak stationary process, and today we will start with some of the most important and most commonly used covariant stationary process in time series analysis. So let's start with this. The first process that we will talk about is a white noise process. Is a white noise process, in short, you write as this, white noise, right? Now, what is a white noise process? Let me write a process epsilon t is the error term, right? I have talked about this, is said to be white noise, is said to be white noise if the following properties hold. Now, what are the properties I'm talking about? The first property is the expected value of this epsilon t has to be equals to 0. Second property, the variance of epsilon t has to be a constant sigma square. And thirdly, the autocovariance of epsilon t and epsilon t plus h has to be equals to 0 for all h not equals to 0. So you can understand this, if h is equals to 0, this is nothing but the variance of epsilon t. If you haven't watched my previous video, then I'll give the link in the description. You can check that out. There I have explained why this is so. H equals to 0 means this is nothing but the variance, right? So for all h not equals to 0, you have to have this condition that covariance of epsilon t plus h, or you can consider t minus h also, any lag values have to be 0. That is, the autocovariance has to be 0 for all h, which basically means that is epsilon t's are uncorrelated across time, right? Epsilon t's are uncorrelated across time, and this is the definition of a white noise process. If these three conditions follow, then what we say? We say that epsilon t follows white noise with the mean 0 and the variance sigma square. And you will see this expression multiple times as we continue with this playlist, right? So this is the most important thing. What is white noise process? White noise means you are talking about the error term epsilon t, and if it satisfies these three properties, then we will say that epsilon t follows a white noise process, 0 mean and sigma square is the variance. Now, one thing that I haven't mentioned here yet, and it's so very important to remember, that in case of white noise, you have no distributional assumption. You have no distributional assumption. No distributional assumption is made. Now, what do I mean by this? Suppose you have a time series data like this, y1, y2, up to yn, right? This is the time series data you are talking about, and t is from 1 to n, right? T is from 1 to n. This is the time series data that you have. Now, what I'm saying is that this time series data can come from any distribution. It could come from binomial distribution, it could come from Poisson distribution, it could come from normal distribution, it could come from uniform distribution, or any known distribution that you can think of. It doesn't matter from which distribution this time series data is derived, right? It does not matter from which of the distribution this time series data is been derived. The only important thing here is that the epsilon t's that we derive in each period, right? Epsilon t is epsilon 1, epsilon 2, and epsilon n. So at each of these n periods, the epsilon t's that you are deriving, if this epsilon t's follows these three properties, then the distribution itself, we will say the process itself will follow a white noise, right? So no particular distributional assumption is made. The time series data can come from any sorts of known distributions. It doesn't matter, only the error term matters because the process is defined in terms of the errors, right? The process is defined in terms of the errors. I hope this is absolutely clear to you. Okay, now if you understood this process, white noise, we can now move into the second process, that is the moving average process. This is also a very important, process that you frequently used in time series analysis. So let us understand what is moving average. In short, MA process. In short, we write it as the MA process. Now, what is the moving average process? Depending upon the degree. I'll talk about this degree in a while. What do I mean by degree? Depending upon degree, moving average process is of three kinds, is of three types. Broadly, we can, analyze the entire process into three parts. The first thing is the MA process of order 1 or degree 1. MA process of order 1, usually we call it order. So MA process of order 1. The second thing that we will study is MA process of order Q, and the third thing that we will go into is the MA process of order infinity, right? So these are the three things that we will study in a while. Now what is this degree? Degree basically means, degree or order, whatever you call it, degree or order basically means the max lag value, that is used while defining the process, right? So what is the order or the degree? This thing is the maximum lag value, that is used while defining the process. Now I will define each of these process one by one and you will understand what do I mean by this order, right? So let us start with the MA1 process. Okay, let me write it formally. A time series process YT time series process YT is said to be an MA1 process, if it can be written as YT is alpha plus epsilon t plus theta epsilon t minus 1, where this epsilon t follows IID white noise 0 sigma square, and alpha and this theta are some constant, or you can consider them to be some scalar quantities, right? So let us understand now what do I mean by all of this. So a time series process YT. So YT is a process like this. YT is T is from 1 to n, right? So you have this data available to you, Y1, Y2, Y3 up to Yn. This is the time series process, right? A time series process YT is said to be an MA1 process if it can be written as this. So if you carefully look at this expression, this is the expression for MA1, right? Here what I have written is that the dependent variable y at the time point t is dependent only on the error terms of the tth period and the error term of the t minus 1th period. So here you see the maximum lag value is 1. That is what I have written here. That degree or order means the maximum lag that is being used while defining the process. So here from this expression, what you can see is that MA process has to be a function of epsilon t's and its lag values. This is a thumb rule. You can consider this to be a thumb rule. If you see any time series process that is written in terms of epsilon t and the lag values of epsilon t's, you will see it will be MA1 process or the moving average process of some degree, right? Here I have considered the simplest case, that is the first degree. So you have only the first lag value. And here epsilon t has to follow this white noise that I have defined earlier in this lecture, right? And independently and identically distributed, right? And this alpha and this theta has to be some constant, right? Some scalar value. It can be 2, it can be 3, it can be some fractional values, right? Any value that we will see. So this is how you define an MA1 process. I hope this is absolutely clear. Now the important question here is that why it is called moving average. Here I have written the reason for that. The term moving average comes from the fact that YT is constructed from a weighted sum of two most recent values of epsilon t's, right? So this is what I have told you here. It is the weighted sum. If you see, it is the weighted sum. Here the weight is 1 and here the weight is theta. So it is the weighted sum of the two most recent values of epsilon t. So epsilon t is the most recent error term, and this is also the next best recent error term, right? So YT can be written as the weighted average of the two most recent error terms, and that is the reason why we call this process to be the moving average process. I hope this is absolutely clear to you. Now only one thing is remained for me to show you that this process is covariance stationary, right? This is the only thing that is left to show that this process is covariance stationary, because I have told you that the process that we will be learning today will be covariance stationary process. So let us show this, that this will be covariance stationary. So I have written this process and epsilon t follows. So this is the MA1 process. Now the first thing to show that it is covariance stationary is expectation of YT, right? Let us find out that expectation of alpha plus epsilon t plus theta epsilon t minus 1. So expectation of alpha is alpha, expectation of epsilon t is 0, plus theta into expectation epsilon t minus 1 is also 0. Because this is epsilon t is white noise, they are independently and identically distributed. So it doesn't matter you are taking tth time point or t minus 1th time point, everything will be following this, right? This is IID. So what will be the value? This is only alpha, right? This is 0, this is 0, this is only alpha. So this basically is a constant term, independent of t, right? This is independent of t. Okay. Now the next step is to find out the variance of the process, variance of YT. So variance of alpha plus epsilon t plus this, right? Variance of a constant is 0. So basically you are finding out variance of epsilon t plus theta variance of epsilon t minus 1. Now you have to remember this, that variance of ax plus by can be written as a square variance of x plus b square variance of y plus 2ab covariance of xy, right? This is the formula. I hope you know this. Then what you can write from here is that variance of epsilon t plus theta square. So this constant will be squared, right? Squared and then variance of that term. Variance of epsilon t minus 1. And then you can write the covariance term, but it doesn't matter. It will be 0 any which ways. Let me write it. Yeah. This term will be simply 0 because epsilon t's are uncorrelated, right? Epsilon t's in the, while defining the white noise, I have written this, that epsilon t's are uncorrelated across time. So this basically means that covariance of epsilon t and epsilon t minus h, this is h, is 0 basically, right? For all h not equals to 0. That is what this means. Okay. So this is basically 0. So what are you left with? You are left with this. Variance of epsilon t is sigma square plus theta square, and variance of epsilon t minus 1 is again sigma square, right? So this will be 1 plus theta square into sigma square. Now if you have, what you can see from here is that theta and sigma both are scalars, right? Theta is scalar. I have defined here that theta is some constant or scalar, and sigma square is also a constant of this. It is independent of t. It is also a constant independent of t, right? So while showing that this is a covariant stationary process, what we usually show, firstly we show that the expected value is, independent of time. Second point is that variance is independent of time, and the third thing that you need to show is that the autocovariance term has to be also independent of time. So covariance of yt minus h, what will this be? This is basically alpha plus epsilon t plus theta epsilon t minus 1. Then you have alpha plus epsilon t minus h. So simply instead of t you are writing t minus h plus theta epsilon t minus h minus 1, right? Okay. Now what we can say is that for h equals to 0, what will happen? This will be covariance of yt, right? Covariance of yt is basically variance of yt. And variance of yt, as we have found out earlier, is 1 plus theta square into sigma square, right? This is what we have found out here. This is variance of yt. And we are not interested in this case. We are more interested what will happen when h is not equals to 0, right? So what will happen? Covariance of, let me write this. Yeah, from this alpha plus epsilon t plus theta epsilon t minus 1. This is as it is. Changes will come here, alpha plus epsilon t minus 1, right? Instead of h you are writing 1, and plus theta epsilon t minus 2, right? Yeah, 1 1 2. Now if you have seen my previous videos, I have given you the method how to solve this. You have to find out the common terms. Here alpha doesn't matter because it's any which way is constant and not be part of calculation. See, epsilon t is only here. Epsilon t is nowhere else, right? So the common term comes from this and this. Epsilon t minus 1, epsilon t minus 1. Again, epsilon t minus 2 is nowhere else. So that will also be 0. So covariance of theta epsilon t minus 1 and epsilon t minus 1, that is what will remain. Now this theta will come out, and covariance of epsilon t minus 1 epsilon t minus 1 is variance of epsilon t minus 1. Again, this suffix doesn't matter. For any epsilon the variance is sigma square, so theta sigma square, right? This is what you will have. Now what will happen for h equals to 2? For h equals to 2, this will be covariance of alpha plus epsilon t plus theta epsilon t minus 1. Then you have alpha plus epsilon t minus 2 plus theta epsilon t minus 3, right? This is what you have. Now let's see, do you have any common term? Epsilon t minus 1, epsilon t minus 2, epsilon t minus 3. There is no common term, so the covariance will be 0. And now if you continue to go on like this, h equals to 3, h equals to 4, so on and so forth, you will see every covariance term is 0. So what you can write, gamma h. Gamma h is nothing but the autocovariance, right? This is how we write the expression. Gamma h is 1 plus theta square into sigma square when the value of h is 0. It is theta sigma square when h is plus 1 or minus 1. Why this is so? Because if you have seen my videos, I have proved that gamma h and gamma minus h are same for covariant stationary processes, right? This I have shown. If you haven't seen the videos, I will give the link of the videos of the playlist in the description. Go check that out. You will understand. So for any lag, so if you consider the positive lag or the negative lag, the values will be the same, right? Gamma h values will be the same. So h and minus h, for every h and minus h, the values are the same. So 1 and minus 1, for both the cases, the values will be theta sigma square. And for all other cases, it will be 0 where mod h is greater than 1. So what is this? Mod h greater than 1 means either h is greater than 1 or h is less than minus 1, right? This is what we want to write here. That for 0 it is the variance, for 1 and minus 1 it is theta sigma square, and for mod h greater than 1, mod h greater than 1 means for any h which is greater than 1 or h when h is less than minus 1, the value is 0. And if you see carefully, every term is independent of t. Every term is independent of t, right? This is the most important thing. So we are successfully able to show that the expected value is a constant which is independent of t. The variance is also a constant independent of t. And the autocovariance function is also independent of t. And what does it mean? This means that the process is covariance stationary, right? This is the three criteria that are that we need to show for a covariant stationary process, and we have successfully showed it. So let me give you a quick recap of what we have done today. We started discussing important covariant stationary processes, and till now we have covered what is a white noise process, and then we have covered what is MA1 process. And in MA1 process, I have given you the definition, how will you write MA1 process, and then I have explained why it is called moving average process, and then finally I have shown you how you will show that this is a covariant stationary process, right? I hope this is absolutely clear to you, and I'll wrap up this session now. And in the next video, I'll be going into what is MAQ process and what is MA infinite process, right? So stay tuned for the next video. And if you like this video, give me a thumbs up and do subscribe to my channel AN Economist. That gives me immense motivation to teach you. And see you in the next video. Thank you for your time.